Video number 170, finding an arc measure between gears. In this problem, we're going to take a look at two gears. Rotating, one leads to the other's rotation at a contact point. Here's the contact point here. Through the teeth of the gears. So as you might see, some people are familiar with cars and that, and gears spin, and that's how one gear spins, it moves the other, this moves something else, and that's how gear relationships work. In this problem, one gear's radius is 7 centimeters, the other is 12.5. How many degrees does the smaller gear rotate when the larger one rotates 165? So when we get 165 degree rotation, here to here, the question is, how much does this one rotate as this one goes 165? Well, we all agree this is 7, 12.5. Now what we have here is this. There's definitely a linear relationship. If you go back and look at the previous videos on arc measure, actually arc length, we can say that arc length is definitely equal to the radius times the central angle. And this is nothing more than like a slope value, if you want to call it that. You can call this obviously a fraction. No matter how you look at this, it's a linear relationship, which means we can use either a direct or inverse variation. However, I'm going to use a phrase called reverse variation, and here's why. If we were to set up a proportion, we would call x the missing arc measure. The arc measure we want to find is the degrees of the smaller gear. So that would be x. So what a lot of people might think to do is you might think to do x over 7 equals 165 over 12.5. Now, ask yourself this question: does that make sense? Think about this. Isn't it true that the smaller gear is going to rotate at a larger amount of degrees? Okay? Which means this would be incorrect, because in order for this proportion to be equal, wouldn't x have to be what? Bam! Smaller than 165. Which is why I'm kind of inventing a phrase called reverse variation. We would actually use the radius of the smaller gear over the arc measure of the larger gear to equal the radius of the larger gear over the arc measure of the smaller. This is not inverse variation. I'm calling this reverse variation, and if you do crunch the numbers, this definitely does work out. There's another way to do this. You can actually go through and find the arc length value of the larger gear and then set it equal to the smaller gear, and you can solve for theta that way as well. But you can definitely set up a proportion. And in fact, of course, we really didn't even have to do this. You could have just started with the 165 and put down theta. 165 over which one? Well, again, this is going to be a smaller degree for a larger gear. So you're going to hook that number up with the smaller amount. And then you're going to put the 12.5. No matter how you slice it, you're going to take 165 times 12.5 and then divide by 7. Bam! 294.6 degrees. Alright? So, any questions or concerns, please do send me an email, and of course, good times.